next section, number 8, is entitled Evaluating Algebraic Expressions. To evaluate an algebraic expression, you really should replace the letter with their number in brackets. That is, if I tell you A is equal to 4, wherever you see A, you should put 4 in brackets. In particular, when A is a negative number. For example, if you have 10A, so let me write down 10A. If you have 10A, and I tell you A is negative 4, well then, for 10 you put 10, and for A you put negative 4, and then you say, oh, 10 minus 4 is 6. And I'm not going to argue with that. Very good. 10 minus 4 is 6. But the problem is that this was 10 times A. You're supposed to be multiplying the 10 and the A. And if you don't put the brackets, you might think it's 10 minus 4. I have students who write 10A is equal to 10 minus 4, which is negative 40. And they get very upset when I mark both of those wrong. I'll probably give them some credit, but to be honest, nothing they wrote is correct. Because 10 times negative 4 is not 10 minus 4. And you know what? 10 minus 4, which is 6, is not negative 40. His equal sign is not correct. Not in the least. 10 minus 4 does not equal negative 40. I mean, let's be honest. This says 10 minus 4. You have to put brackets. Okay, you have to put brackets. If B is plus 4, B is 4. Well, if you have 10A or 18A, and you don't put brackets, that is, you write 18 and then A, well, yeah, you get 184. I agree with that. I meant to say 10B. You get 184. If you just write the 18, and then next to the 18, you put what B is. 18B. Okay? But again, you really should replace the variable with the number in brackets. And then we all know, oh, that's not 184. I mean, nobody writes 184 this way. Everyone writes 184 that way. If 18 times 4, which happens to be 72. Replace the variable with their value that is known to be in brackets. What on earth am I saying? Well, suppose you were told that A is equal to 4, B is equal to negative 5, and C is equal to negative 2, and you're asked to evaluate A plus BC plus 2. Well, the letters, you put brackets. A plus B, C plus 2. Now plug in the values for the variables. For A, I'm told it's 4. For B, I'm told it's negative 5. C is negative 2. Let me just write it out again. I'd like a little bit more space. There are addition and subtraction signs. They separate what you're adding and subtracting. It's this number plus this number plus that number. Those are the terms that I just boxed. The first term is 4 plus the second term is 10. A negative times a negative is positive, and 5 times 2 is 10. Plus the last term is just 2. So we have 4 plus 10, which is 14. Don't forget plus 2, and parentheses, brackets, curly brackets, they're all the same. Be told that x is equal to 4, and y is equal to 5, and z is equal to 3. And you're asked to evaluate x minus 3y plus 4z all over x. Well, copying the numerator, you get x minus 3y plus 4z all over x. Anytime I see a letter, I put brackets. X is 4. I see x first, so x is 4. 3y. Y is given to be 5, so there's my 3y. Plus 4z. Z is negative 3. And I'm dividing by x. I'm dividing by x, and x is 4. Okay. So the numerator is this number minus that number plus that number. Notice the terms, which I just put the brackets, the clause around, are separated by addition and subtraction symbol. The first term is 4. This is 4 minus 3 times 5 is the second term, which is 15, plus this last term is negative 12, divided by 4. Okay. How much is 4 minus 15? Well, I would read that backwards. It's 15 minus 4, which is 11. If I read it backwards, it becomes minus 11. Plus negative 12. Two symbols next to one another. The rule says to isolate them with parentheses. Okay, divided by 4. Well, we're not adding 12. We're not adding 12. So we must be taking away 12. If you think about it, if you take away 11, if you go over to the cookie cabinet and you take away 11 cookies, and then you go back and you take away 12 more cookies, a lot of students would say, I'm going to take away 1 cookie. That really puzzles me because I see 11 cookies in your left hand and 12 cookies in your right hand. Sounds to me like you took away 23 cookies divided by 4. If you like, the way I taught you before is to read this backwards, so it becomes 12 minus negative 11 with a negative sign in front. And since this number is not 11, it's not 12 minus 11, so it must be 12 plus 11. 12 plus 11 is 23 with the minus in front, negative 23. Then you should ask yourself if you can reduce that. The answer is no. And you should ask yourself, can you clean up the sign? A negative divided by an understood positive is a negative. So saying negative 23 over 4 is fine. You could write it as 23 over 4 with the negative sign in front. I tend to write it this way. I hardly ever write answers that way, but that's my taste, that's my style. You can put it with the negative sign in front. Let's try another one. Suppose I tell you Q is 4, R is negative 2, and S is 3. I ask you to find the sum of Q, R, and S squared. So it's Q plus R plus S, then I square. You want to put round brackets? Fine. I put those square brackets. Doesn't matter. Q is 4. Q is 4. R is negative 2. And and s is 3. How much is 4 plus negative 2? Well, it's not 4 plus 2, so it's 4 minus 2, which of course is 2. So this is 2. Don't forget the plus 3. And you 2 plus 3 is 5, and you square it. You can put any type of brackets you want. It's 25. Here I put the square brackets. Let's change the next line. Now I put curly brackets. And in the last line, in the next line, I put the round or parentheses type brackets. It doesn't matter, just see parentheses. It doesn't matter. When I see this here, I can, if I choose, to see this. The type of brackets don't matter. I have every right, if I choose, to see the curly brackets. Doesn't matter. Get over that. The type of brackets don't matter. The only thing is this here would make no sense. This would make no sense. If you put curly brackets here, you cannot put the round brackets here. If you put square brackets here, you can't have curly brackets here. They have to be the same. I opened it with curly brackets. I closed it with curly brackets. I opened it with round brackets. I closed it. I opened it up here with the square type brackets. I closed it with the square type brackets. That's the only exception. This here is nonsense. Teacher writes that on an exam. You say, thank you, teacher. I don't have to do this problem because it makes no sense. Whatever you do, you don't rewrite the teacher's problem. Because assuming the teacher was wrong and what you want to write is correct, you might go and make a mistake after you correct it. Just say this problem is not valid. And how about this one? How much is 3 times r take away s all squared plus r plus s squared, given that r is 5 and s is 3. Okay, so 3 brackets, r in brackets, the minus sign, s in brackets, close the bracket square. There's this 3, there's the open bracket, r is parentheses, there's the minus, s is just parentheses, there's the closed bracket, there's the square, now their plus sign, now r, now their plus sign, now s in brackets, then the square, and that's it. And you should be able to do what I just did. You have to justify everything. Every little detail must be justified. You have 3, and then you have brackets squared, and inside the brackets you have r minus s. That was this piece. Plus r. Plus r. Plus s squared. Now you just plug in the values. R is 5, s is 3. It was r minus s. R was 5, s was 3. Plus r. R is 5. Plus s squared. Okay. The terms are separated by addition and subtraction symbols that are not inside brackets. I'm not going to argue that that's a subtraction symbol. But you can't argue either and say it's not in brackets. Of course it is. It's inside parentheses. So these are the separators. This term, of course, is 5 plus, and this term, 3 squared, is 9. The first term that's a little bit harder is 3 times 5 minus 3 squared. It's 3 times what's in the bracket squared. Well, 3 is 3. What I'm squaring is what's in the bracket. What's in the brackets is 2. 2 squared is 4. So it's 3 times 4, or 12. 12 plus 5 is 17. Don't forget to write down plus 9. And 17 plus 9 is 26. Now, when you want to sketch a function, you want to draw a function, which we won't do, but you need to make up a table. For example, if I told you y is equal to 3x minus 2, you want to find some points on this line. This is a line. Y is equal to mx minus b. So you have x and you have y. This is just another way of writing y. And we'll say y equals that. So now if you can state in words what this is saying, then you'll have an easy way of getting y. If you triple x, you multiply x by 3, and then you take away 2, you get y. Write down some x value, and we'll multiply by 3, and then take away 2. If I multiply that number by 3, I get 0, and I take away 2. 0 take away 2 is negative 2. And you want to write it down. 3 times x minus 2, x is 0. 3 times 0 is 0. Take away 2, negative 2. It's a lot easier to do it in your head. If I multiply that number by 3, I get 9. Then I take away 2, I get 7. 3 times x minus 2. X is 3. 3 times 3 is 9. Take away 2 is 7. I multiply that number by 3. I get negative 12. I take away 2 more. Negative 14. 3 times x minus 2. 3 times negative 4 is negative 12 minus 2. You take away 12, and then you take away 2. You took away the sum. You go to the bank and you take out $12, and you go back later and you take out $2. You didn't take out $10. Get over that. You didn't. I mean, you already took out more than $10. And then you go back and you take out more, and now you only have $10. When you took out the $12, you have $12 in your hand. If you go back and say, give me more money, how are you only going to have $10 in your hand now? But the way I said to do that is to do 2 minus negative 12. I didn't read it backwards, but since it's subtraction, put a minus in front. There's the minus in front. This is not 2 minus 12. So it must be 2 plus 12, which is 14. The negative sign, 2 plus 12 is 14. Negative 14. 1. Multiply it by 3, get 3, and then take away 2 is 1. 3 take away 2 is 1. 3 times x minus 2. 3 times 1. 3 times 1 is 3. Take away 2 is good old 1. And you can plot those points and then graph your line. So this is another type of situation where you would want to evaluate. Let's try some more. Suppose you were told that y is equal to 3 over 5 times x. So you have x and you have y, which is 3/5 times x. Now, you don't want to end up with fractions. You want to pick x values. You want to pick x values so 5 goes into them. 5 goes into every number on the 5 table, including the negatives. And you have 5 times 0, 5 times 1, 5 times 2, 5 times 3, etc. You have 5 times negative 1, 5 times negative 2, 5 times negative 3, goes into each of these numbers. I know they do. 5 times, say, 7. I know 5 goes into it. Goes into it 7 times. 5 times 4. 5 goes into it 4 times. 5 times 14. 5 goes into it 14 times. 5 goes into every number on the 5 times table. So when I pick x values, they shouldn't be just random x values. They should be x values that are on the 5 times table. Like 0, 5, negative 10, 30, and negative 20. Those 5 numbers, they're on the 5 times table. This is 5 times 0, this is 5 times 1, this is 5 times negative 2, this is 5 times 6, this is 5 times negative 4. Okay, so when x is 0, well, let's do it here. You have 3 over 5 times 0. Well, you should know any number times 0 is simply 0. And I guess we don't have room. The next one, 3 over 5 times x, where x is 5. Well, 5 goes into 5 one time. 3 times 1 is 3. We have 3 over 5 times 5. The 5's cancel, and you get 3. In the next one, you have 3 over 5 times negative 10. 5 goes into negative 10, negative 2 times. 3 times negative 2, negative 6. Do it up here, please. 3 over 5 times 30. X is 30. 5 goes in here into 30, 6 times. 3 times 6, 18. 3 over 5 times negative 20. If you hate doing 5 into a negative number, not a problem. Get the sign first. 3 over 5 is a positive number. 20 is a negative 20 is a negative number. A positive times a negative is negative. Now, ignore signs. The problem is now 3 over 5 times 20. I do not see that negative sign anymore. 5 goes into 20 4 times. 3 times 4 is 12. Final answer, negative 12. Okay. No fractions. None of these numbers are fractions. None of them. Why? Because I pick numbers for x that 5 goes into. I pick 5 times 0, 5 times 1, 5 times 2, 5 times 3, or I could have picked those. I pick numbers on the 5 times table. That's going to finish this section on evaluating algebraic expressions. Good luck.